Let's try doing this. Give the third approximate value of the zero function y equals sine x plus tangent x. So if we have sine x plus tangent x, so that's y is equal to sine x plus tangent x. And then it says that the problem would start iterating at x sub 1 is equal to 1.24. So x sub 1 is equal to 1.24. Now you should be very careful with this because it says here that it is already x sub 1. In that way, this value was actually obtained from the first iteration process. So x sub 0 would have been something like this value. We don't know about it, but it already started, and then this is the first derivative. So therefore, the first approximate value. So in this case, what we'll be able to get is x sub 2 if we try to use this. So we have 1.24, and then we just need to have 2 iterations so that we would be able to get x sub 3, because that's actually the third approximate value of our equation. We just have to do it twice instead of 3. So in this case, that's 1.24 minus, so we need to take sine of 1.24, and then remember, this is always in radian. So that's plus tangent 1.24, and then you divide this by the derivative substituted with this value. So we have cosine of 1.24, and then the derivative of tangent is secant squared. So plus secant squared of 1.24. So in this case, you'll be able to get an answer that is equal to 0.84652. And then if we want to find x sub 3, so this should be the third approximate value, you would do the same thing, and then you just use the same method, and then the answer, it would give you a value that is 0.2074. Okay, so I think that's our answer in your module, 0.2074. Okay, so that is the third value. And if you're asked, is this the 0? So you do the same thing, and if the answer is 0.2074 again, then that is the 0 of the function. But apparently, x sub 4 is not the same, so it's not the 0 of the function. But the question just asks for x sub 3, the approximate value, so you just report this answer. It actually depends on the question. Okay, and then for number 2, from the equation given problem number 1, give the real 0 of the function closest to 1.24. So you just have to perform this again until you get the same answer. Yes, correct. Until you get the same answer, meaning that something like L minus R in the calculator, meaning equal to 0. So that's it for your the first one that you use, and then the last one you subtract them, and then it should be 0. So it's also saying that they should be the same. So in that case, x sub 4 is 1.5793 times 10 to the negative 3, and then x sub 5 is actually equal to 6.565 times 10 to the negative 10. So knowing the since we have the basic knowledge of limits, as you can see here, this x sub 3 and then x sub 5, it's actually getting lower and lower, and then up to the point where in this negative to the negative 10 is actually very small. So that's almost 0. So you have to expect that your answer should be 0 at x sub 6, because this one is a fairly small value. And you can still proceed with x sub 7, but you will just get the same result. So at 6th and 7th, you'll already obtain the same answer. And your answer should be that in this case, the real 0 is 0, because that's it. That's the result of our iteration. But what if you're asked, how many times do you have to iterate in order to get the first real 0? So you should be answering something like 7th, because at 6th it's 0, so you have to check that on 7th if this would give you really the same value. That's the same way, or that's the same concept if you're asked from the problem number 1, how many iterations that you have to do, how many iterations do you have to do in order to get the 0 that is closest to 5. So your answer should be 7, because at 6th it's quite close to 5, but it's not actually really equal. But at 7th it's actually already equal to that value. So that's a fairly good answer. So that's 7th. You can also say more than 6 iterations, but if you're asked to the exact, the exact number of times, then you should be giving the one value. So that's it for our approximation, and of course the differential sign approximation. So I hope you've understood this problem. So the next topic I'll be discussing about approximation using tangent function, and then we proceed with differentiation of the transcendental function, which will of course end all the rules that we need to memorize in differentiation. Okay, thank you.